All right, I believe it is recording. So today we're going to finish chapter 7 and then go over chapter 8 and probably finish chapter 9. So we're going to do a bunch of stuff about climate. No time for a video today. I was looking at, has anyone seen the documentary Gasland? It's kind of in the news as being a controversial. It's about fracking technology, which is getting at oil deposits. It's about pollution and whatnot, so I thought about trying to see if I can get my hands on a copy of that. Maybe watch it next week when we start moving into soils and tectonics and things like that. But like I said, chapter 7, 8, 9 today. And we went over a bunch of stuff from chapter 7 already, but just to reiterate, to get your weather, your precipitation, you need some type of uplift. There's a number of different type of uplift mechanisms. It can just be from convection, from the heat, or that air mass can be forced up if it hits a mountain, something like that. And very often you'll have this air mass that has moisture in it, but it's not until it's forced up that it's made to precipitate out into a cloud or a little hat. And again, in convection, you'll see the more anvil-shaped storms, right? Because that's going straight up from the heat. All right, to move on to other types of precipitation, snowstorms, blizzards. Low visibility is called a whiteout. It's kind of interesting to read a geography book that's written for the entire country, because there's a lot of these things that we kind of take for granted that people know. And sometimes these blizzards can leave quite a bit of snow, especially in high snow drifts. Although it feels like it's been a lot of years since we've had a really, really high snow. But I remember some that were, pretty high back in the day. Other types of storms. Tornadoes, the most violent storms on the face of the earth. The most violent storms. But, although they're the most violent, they're relatively small in size. There's a quiz question asking if they're the biggest storms, so beware for that. Most common in the interior of North America. This is why we kind of know about these more than a lot of other places that would read about them. So people before reading this chapter heard the term Tornado Alley. What does it refer to?
Well, usually it's Texas, Oklahoma, Kansas, the Corn Belt states, as they call them, or the lower states, Arkansas, Missouri, right in that area there in the south.
More relatively flat areas on the plains and stuff where they develop blacks. That's what
Right. We talked about that general cyclone storm system that in general goes across North America. Well, the center of that tends to be these states, and as you said, there's not a lot of mountains and different terrain to kind of block them from forming. But look at them here as well. So small but intense cyclonic storm. So again, a cyclonic, that means low pressure, it means pulling up, right? Low pressure, right? So it's as if the air is being pulled off of you, low pressure. People will look at these and refer to them as high pressure just because they feel like it should be high pressure because it's a storm. But if it's going up, it's low pressure. And some of these can be miles wide. I don't think we've had any of those for quite a few years. Has anyone ever seen a tornado in person? A couple people? How long ago?
A few years ago, down in Hammond, Baldwin area. It went through Hammond, and I was in Baldwin working.
Yeah. You how far away were you from it?
It's like maybe 3 miles away.
So you could see it? Right. Someone in the back?
Yeah, I saw it during the Hugo tornado. It was a half mile from my house.
Half mile from my house. You saw it? No?
I have not seen one.
There's a hand over here. All right.
I saw the same one about 12, 15 years ago out of the bank. It's the water in the wash house and stuff good.
Oh wow.
Dropping down the road.
I saw one, it was miles away, and actually, I can't remember why, I was in the car with some people who were driving, And I told them there was a tornado behind us coming toward us, and they would not believe me. I mean, I make a lot of jokes, but they would not. And I said, just look through your rearview mirror, and they did. And they still don't believe me when I say things. So Doppler radar, the advantage of Doppler radar is that it can show the contortions inside of cloud systems, so you could actually see these before a funnel cloud would appear, right, as it's starting to spin up in the atmosphere. So this is why you always get all the news stories that seem to come on whenever you're watching a good show, where they decide to take up the entire screen, like a little county in like the southwest pocket of the state that might have a tornado. That's my pet peeve, sorry. And there's a lot of storm chasers around the United States. Actually, I have a cousin who's at school in Kansas. Perfect place to be a tornado chaser. He's getting his degree in geography and atmospheric sciences. And he likes to chase storms. And actually, these storm spotters can be very useful in trying to track. Because as good as Doppler radar and other technology are, if you have people on the ground who are taking more direct measurements of the air pressure and even just taking pictures, that can help a lot for trying to depict or guess where it's going to go. So again, Doppler radar, right? It could show the contortions within a storm. So, you know, something like a satellite view, you would just see this as all clouds, right? But Doppler radar, because we can see inside of it, you can see where that real twisting and churning is. And you can see that perhaps, you know, a place like this might funnel cloud. Funnel cloud is, of course, what happens before you actually get the tornado. So average number of tornadoes per year. This is why this is called Tornado Alley, right? Although, you know, get a lot over here too, right? Actually, boy, right, is that Chicago right there? I don't seem to specifically remember a lot of tornadoes happening in Chicago. Or Florida, but I guess they do, right?
Florida gets a lot of water spouts that come in onto land,
Yeah.
but usually once they hit land, they kind of break apart.
Yeah, well, water spouts, we'll talk about that a little later. But they're generated by that moisture in the air, and very much like a hurricane, once they go over land, they lose their energy and they will kind of peter out a little bit. And the tornado season changes depending on how high in the sun different places are, kind of how dried out has become in these different areas. Right? So we're getting into our peak tornado season here. There's a scale about how much damage different tornadoes will have, and I can go through every single detail of every single tornado. So over the ocean, a similar thing that might lead into a waterspout or a hurricane is what's just called a weak tropical disturbance. You'll often hear this if you're watching the news. They'll say there's a tropical disturbance. What does that mean? Well, that means a similar type of thing to a tornado, where you're beginning to see the contortions in the atmosphere that could become something, but maybe not. Well, why is this cut off at the top? You can see it, but... Alright. So as I was saying, hurricane. Because these are driven by so much more energy than tornadoes, because they have all this moisture in the air, they tend to cause a lot more damage, and most of the damage itself is actually done by the storm surge when they hit land rather than the winds themselves, although the wind and rain can do lots of damage as well. We already talked about Hurricane Katrina a bit, so I won't reiterate it, but these things can do a massive amount of damage. What we didn't talk too much specifically last time was about that storm surge. So although you can get a lot of rain, a lot of what you would normally experience here in a place like Minnesota with a storm, a lot of high winds, even hail, it's that storm surge. If you have 15, 20, 30 feet of just a wall of water come up, that's what's going to do your damage. And then when it goes out, it will leave so much debris behind that will also require a lot of digging out. This is one of the reasons why you'll see a lot of places where they'll build up those protective walls. Is if if you have a storm surge that's only a few feet high, you could block most of it. Like I said, we already talked about hurricanes quite a bit, so I'm not going to go through too many details. But I do have these on your notes if you want to use them to study. One thing that we didn't talk about is similar to a tornado alley, there are normal hurricane paths. You can call them hurricane alley if you want. Now you're not going to hear about some of them too much. Like you don't really hear about these hurricanes because they don't hit land, right? They just go off into the ocean. It's these ones that you always hear about on the news, right? Every now and then you'll hear about this, but these are primarily the ones you'll hear about. And you'll see these different names, typhoons, cyclones. These are all the same thing. Just different places, they have different names for the same thing. Cyclone is a good name though because it's very apt, right? Because again, it's a cyclone. It's a low pressure system because it's pulling up that air. We also talked about predicting hurricane paths before. You know, when you see these on the news, and you see the probability of where a hurricane's going to go, and then you can do an analysis afterward about, well, where did it really go compared to where it said it would go. It seemed to mostly go in the center of their predicted path, maybe a little bit to the east, but not too bad. And these are 3 different hurricane tracks, oops, all from 2004. And you can see very similar path, right? So if there's a place that you would call a hurricane alley for the United States, you'd be going right up Florida there. Alright, that was finished chapter 7.